All right, now we're going to work on solving linear equations in one variable. Okay? So that means we're going to work on trying to get the variable by itself. Now, if you look at what we have there, 7 is being multiplied by z, and then 5 is being added to that. And I want you to keep in mind these two guidelines that we talked about earlier. So we need to undo whatever's been done to the variable, and then if we do something to one side of the equation, we have to do it to the other to keep it balanced. All right, keep your stuff organized and lined up nicely. Do not just try to guess and check your way to the answer. You want to get to where this process almost feels automatic to you. So do you see how there's a plus 5 there? I can get rid of that by adding a negative 5 or subtracting 5 from both sides. Okay. So I'm going to come in and do that. All right, now when you type in, you can use a calculator. When you type that in, you can either type in that you're subtracting 5 or type in that you're taking negative 9 and adding a negative 5. Those say the same thing. Okay. And or just do it in your head if the numbers are small. So we'd have negative 14 on the right side, and we subtracted 5 to make the 5 go away, because 5 take away 5 would be 0. So on the left side, let me get my scheme down. So on the left side, we have 7z, and on the right side, we have a negative 14. I like to put an extra mark on my z, otherwise they sometimes look like 2's. Okay? So remember, I'm still working on trying to get this by itself. So there's a 7 that I need to get rid of, and it's being currently multiplied by z. So to get rid of it, I'm going to divide by 7, and if I do that on one side, I have to do that on the other. So on the left side, when I do that, I'm left with just my variable by itself, and on the right side, I have negative 2. Okay? Now, that's the answer that you would put in, but if it's important, like a quiz or a test, you ought to do the check, which is to take the equation, which was 7z plus 5 equals negative 9, and where z used to be, put a negative 2 in there, and then just use your calculator to see if you wind up having the two sides being equal. So negative 14 plus 5 would equal a negative 9. I know I'm right without waiting for them to check it for me. Now, sometimes there'll be an equation just like that you're trying to solve, but it'll feel a little bit harder sometimes if the variable is on the right. But remember that an equation is kind of like a seesaw. It's just saying the two sides are equal. So you might find it better, like you might do better, if you put just interchange the two sides. Let me line it up still with that equal sign. I'm going to rewrite it. Now, if you've done a lot of solving of equations, that may not be necessary, but I find that my students sometimes mess up a lot when the variable that they're trying to solve for is on the right-hand side, and they do better when it's on the left. So we're trying to get that a by itself, and the a was on the right side, so I just interchanged the two sides, which is always okay to do. Okay. Now, when I'm looking at this, I have 6 being added to the variable term, but I also have negative 4 being multiplied by a. So I'm going to undo the adding of 6 by subtracting 6. Okay. Keep things, if you can, keep your equal sign kind of lined up. Keep straight about where you are in the process. So the 6 minus 6 cancels out. I have a 6 on the right. And on the left, all that's left is negative 4a. Now, what's going on between the negative 4 and the a is multiplication. And division is what undoes multiplying. So I'm going to divide. And here I want to divide by a negative 4, not a positive 4. Okay. See, this is different. Up there where I had a plus 6, I subtracted 6 because when you're adding and subtracting, you need the signs to be opposites to cancel out. But since that was multiplying, I need to divide by -4, because what I want this to be, -4, any number divided by itself equals 1. So that means now I have the a by itself, and on the left-hand side, all I've got left, so that would be equal to -6/4, which I can simplify by dividing by 2 on the top and bottom, and I get a equals -3/2. All right, now I'm not going to do the check every single time, but I want to do it one more time. So if I were going to check that, I'd go back to the original equation. Where the a used to be, I'd replace it with what I think the answer is. And then I'd just work out, I'd look to see if that right-hand side, when I do all of that, turns out to be 12. And you can learn to use the fraction keys on your calculator. On the one I use, the TI-30X2S, which you might have, you can find it pretty easily. When I use that one, the fraction keys are the ABC button. Looks like that. So I can type in 3, I think I can do -3, then hit -3, then hit the ABC button and put in a 2. And when I do that on my calculator, it looks like this. It looks like the way the fraction looks is like that. And then I can just take that times -4 and then add 6 all at the same time. It has order of operations. So I can just type that in, and when I see that it equals 12 like it's supposed to, then I know I'm right. So I know this answer right here is correct. Okay. All right, so one more of that kind, where there's only one term with a variable in it, would be like question number 3. So on that one, if I were trying to get the x by itself here, only issue is I have decimals. So it might be a little harder for me because we didn't really review operations with decimals, but you'll be able to use your calculator on all of these. So you're going to come in and get rid of the -4.2 by adding 4.2. Now, if you are trying to do that by hand, your decimals do need to be lined up, and then you can add straight down and get 14.5. But it's okay just to do 10.3 plus 4.2, and you'll see that on the calculator. All right, so we're left with -2.5x, okay? All right, now I need to get rid of that -2.5, and there's a multiplication symbol in between those two. So I need to undo that by dividing by -2.5, because that causes that to be 1x, which is x on the left. And then I just take the 14.5 and divide it by the 2.5. And I didn't even put in the negative because I already knew it was going to be negative since those signs were different. Okay, and then you can do a check. But if you're doing homework, you might as well just put it in and let it check it for you. Okay, and then if you're wrong, go back and look for a sign error first. That's usually where the mistake happens. All right, now, sometimes we have this issue, and I need to tell you a couple things when you're working through what you see on question number 4. You see how that 3 is out in front of that 4x plus 2, which is in parentheses? There's an understood times between the 3 and that quantity 4x plus 2. For this problem, you would actually need to use a property called the distributive property. So we're just going to jump right in and learn to do this by example. So that 3 would get multiplied by the 4x, but it also have to get multiplied by that 2 for it to wind up having the same value as what you had before. So that's called the distributive property. The 3 needs to be dealt to both of those terms. So you would do the 3 times the 4x and get 12x, and then the 3 times the 2 is going to give you the 6. But then bring down the rest of the problem so you don't lose track of it. Okay. Now, something else, another reason I put this one on there is that now, here's my equal sign way over here, okay? And what I've got are a couple of terms that have x's in them, and they're on the same side of the equal sign. I'm going to need to get those to be combined. They're what we call like terms, so I'm going to combine my like terms. So if they're on the same side of the equal sign, I'm really just thinking I have 12 apples, and if I take away 6 apples, right? That's the 12x minus the 6x. I'm going to have 6 apples left. So I'm really just, the calculation I'm making is just 12 minus 6 because they're on the same side of the equal sign. So they're like terms is what they're called. You know, we have to, and if it was 12x, but then minus 6y, like if it were this, that can't, I didn't make that look like a y, and I meant to, minus 6y, these are not like terms. You can't put them together. It's like 12 apples, but I'm trying to take away 6 oranges. So I couldn't do that. That would be fully simplified. Okay, so if they have the same variable like that, first thing you're going to do is combine your like terms. That would be 6x. Then we have a 6 already. And then on the right side, we have minus 30. Now, do you notice that that problem, number 4, where we are right now, looks like the way this one started out? Okay, so that's what's going to happen on these more complicated equations. It's like they start out looking messy, but at some point they're going to clean up and look just like question number 1. So once you get the hang of, ooh, I need to get rid of a plus 6, so I'm going to subtract it. You know, you get to where you can do this quickly and confidently. So that would be 6x, the 6 minus 6 went away, and then a negative 30 and a negative 6 would be negative 36. Okay? At this point, I still have, the variable still has a 6 in front of it. So I'm going to divide by 6 because that's multiplication, and division undoes it. That would give me 1x. But if I divide by 6 on the left, I have to do so on the right. So I have x equals, and a negative divided by a positive is going to be negative, and it'll be a negative 6, and I'm done. Okay. All right, again, you should possibly pause the video and try these, and then just check and see if you're on the right track or not. I'd like to do 2 more before I stop the video. So on question number 5, I have this 4x minus 2 business going on, and that 2 has an understood multiplication there. So I'm going to need to get, multiplication has to happen before I can do all this adding and subtracting, you see. So I'm going to distribute that 2 to remove the parentheses. So that'll be 4x minus 2 times x, and then see how there's a negative times a positive? That's going to be minus 14, and then bring down equals 9. Okay. Now, on the same side of that equal sign, so here's that equal sign, which is like a wall, the 4x and the 2x is going to be really important when we get to number 7 that you see the difference between 5 and 7. The 4x minus the 2x, 4 apples take away 2 apples would be 2x, bring down the minus 14, and the equals 9. And now we're back again to question number 1. So I'm going to come in and add 14. And when I do, the minus 14 is gone, but I have a 2x, and on the right side I have a 23. Okay, and then the 2 is being multiplied by x, so I'd like to divide by that to get the x by itself. So I now have that 1x, that x is going to equal 23 over 2, and that's a perfectly acceptable final answer because there's no number that goes into both 23 and 2 evenly. But you could also write it if you did it on your calculator. Did 23 divided by 2 on your calculator. You might get that that's equal to 11 and a half. or 11.5. All of those are just different forms for the same exact number. No rounding or anything would have been done. So any one of those would have been acceptable, but do watch in homework. If they say they want it as a fraction, then this is the fraction. If they say they want it as a mixed number, that's the mixed number. And if they say they want it as a decimal, that would be this one, okay? But they're all technically equivalent. All right, one more, because it's just like the others. All it is that it's got a fraction, and I want you to have a way of dealing with that fraction that's gonna be easy to do. So just wanted to work out a way to handle that. All right, first off, this is one where the variable that we're trying to get by itself is on the right. So I recommend that before you get started, you switch the two sides around, because I just find students do so much better. They make better decisions about how to get the variable by itself if it's in its usual location. Okay, and if two kids are sitting on that seesaw, does it really matter who's on what side? It's okay to switch the two sides, isn't it? It would still be balanced. All right, now we're trying to get the m by itself. So let's go ahead and get rid of that 5, like we've been doing, and just subtract it. When we do, we get a -2 on the right, and we have 2/3 m on the left. Now, you could, I'm going to show two ways of doing this. So you could, since that 2/3 is being multiplied by m, and you're using a calculator, you could just divide by 2/3 on both sides. So you could type in -2 divided by 2/3 using your fraction keys, and I'm going to do that now to see what my calculator says when I do that. So if I do it using my fraction keys, 2 divided by, and then 2 ABC3 to make it be a 2/3, it does it for me nice and easily and tells me my answer is -3, okay? And you know, we divided by 2/3 because then 2/3 divided by 2/3 would equal 1 times m, which is m, and there you have it. Now, in reality, what most people do once they know a little more on this, will just clear the 3 out. Get rid of that, because since it's in the denominator, it's like it's 2 divided by 3 times m. So they multiply by 3, and that just clears the fraction and leaves you with 2m equaling -6, and then you come back in and divide by 2. That's how I usually do it. That way I don't really go to my calculator at all. Okay, so those are two ways of handling that one.